In this video, I'd like to talk about what are known as relative maxima and minima, specifically regarding different function types. So the general idea with these, since we're talking about relative maxima and minima, is that we're looking for local peaks and valleys. So let me write that down. So these are what we call local peaks of the function and valleys of the function. And the word local just means we're looking at points around the peak and around the valley. If we're looking for the largest possible value of the function, we use the term absolute, which we'll look at in a later video. So for instance, in this problem, we are going to mark the maximum points on the graph, or the relative maximum points. So we're looking for essentially the peaks of the graph. And visually speaking, we're looking at this point, and this point. So these are all going to be our relative maximum points. Since if you look at the points around these points, everything else is lower than it in terms of its y value. So in all of these, we're considering the y value of our function. And this could be f of x, g of x. We're not told what the function is, but we are looking at these peaks, these relative maximum points, where every y value near it is lower than it. And likewise, if we're looking for relative minima, so that's going to be all of these valley points. So maybe that point, and that point. These are what we call relative minima. And I mentioned we're also going to talk in a later video about absolute maxima and minima. And when the term absolute is used, that's just looking for either the highest overall point on the graph in terms of its y value, or the lowest overall point on the graph in terms of its y value. So for instance, this point right here, this is what we call the absolute maxima, since it's larger than every other function value or y value on the blue curve. Whereas this point right here, as you can imagine, this is what we call the absolute minima. So this exercise is really just getting used to the vocabulary and then picking the different points on the graph. So let's look at some different example problems. And for this one, we need to mark all the relative minimum points. So remember, these relative minimum points, you can think of these as the valleys of the function. And they're the lowest point in that valley. So for instance, right here, this would be a relative minimum. And then everything increases. We reach a peak. This is a relative maxima point. Then it decreases and it reaches a lowest point in this valley right here. So in this graph, these are our two relative minima points, our relative minimum points. So let's keep going. Look at two more examples. So this one, we want all the relative maximum points. And again, these are the peaks of the function. So imagine a mountain range. Each peak in that range is what we would call a relative maximum point. Now, in this one, there's actually just one. So that point right there. You might be thinking that maybe this point or this point, but we're looking at all points around there. And yes, it is true that before that point, for more negative x values, that they are lower. But after that point, the y values are increasing. So they're going to be higher than that. So that point and its symmetric point over here, neither of those are maximum or relative maximum points. And for this one, the relative minimum points would be here and here, since those seem to be the very lowest with a y value of -8, it seems. So let's do one more problem, just so that we can get the hang of these. And in this one, we want to look at the relative minimum points. So again, we're looking for the valleys. So trace along your function here, and when you reach a lowest point and start going up, that tells you you pass through one of these relative minimums. And so this is the lowest point of the valley here. And then this would be a relative maximum. Then it goes all the way down, and we have another valley where once it starts going up, you've passed that minimum point. And so this point right here is our relative minimum. Since again, if you look at all points around it, they all have higher y values. Just like this one, all points around this one, the y values are all higher than it. So that's why these are both relative minimum points. Whereas this one actually would be called the absolute minimum, since out of all the points, this is the lowest one. But like I mentioned, we'll look at that in the next video.